Hello everyone. Today our lecture CSIR NET-PYQ discussion. So this question based on CSIR NET 2011 June. So question basically came this question sequence of a function. So let's start. Here say that let f n x equals to x to the power 1 by n for x belongs to closed interval 0 1. Then limit n tends to infinity f n x exists for all x belongs to closed interval 0 1. Limit n tends to infinity f n x define a continuous function, and third option say that f n convergent uniformly on closed interval 0 1, and fourth option say that limit n tends to infinity f n x equals to 0 for all x belongs to closed interval 0 1. Okay, so here first we find limit of a function. Limit of a function means limit n tends to infinity f n x find. So when x equals to 0, then f n x of 0 equals to 0, and when x belongs to 0 to open interval 0 to 1, then limit n tends to infinity x to the power 1 by n goes to 1. So there exists limit. So first option say that limit n tends to infinity f n x exists for all x belongs to closed interval 0 1. So obviously this is correct, first option. Second option say that f is defined a continuous function on closed interval 0 1, but we see that here x equals to 0, f n of 0 equals to 0, and x equals to extending to 0 plus this is 1. So here x equals to 0 is not continuous, so here option B is not correct. Fn continuous convergent uniformly on closed interval 0 1. It is pointwise convergent but not uniformly convergent because two limit exist, x equals to 0 to 0 and x equals to x open 0 closed 1, that is 1. So this is also incorrect. And limit n tends to infinity f n x equals to 0 for all x belongs to closed interval 0 1. No, it is x equals to only x equals to 0 has limit f n x equals to 0, others point value is 1. So it is also incorrect. So here option A is correct. I hope it is clear to everyone. This question based on CSIR NET December 2011. This is question came from Riemann integral. So given question say that define f such that closed interval 0 1 to closed interval 0 1 by fx equals to 2 to the power k minus 1 by 2 to the power k for x belongs to closed interval 2 to the power k minus 1 by 2 to the power k minus 1, 2 to the power k minus 1 by 2 to the power k greater equals to 1. Then f is a Riemann integrable function such that which option is correct. Okay, so f is Riemann integrable, so then we can write summation of lower integral to upper integral f of x dx. Then I put fx equals to given function and we get this solution, we get this type of summation. Okay, and we get this value and it is 2 by 3. So integral fnx integration 0 to 1 fx dx, we can find 2 by 3. So 2 by 3, which option exists? Option A exists. So here first option is correct. I hope it is clear to everyone. Next question say that if it's given that the series summation of n equals to 1 to infinity an is convergent but absolutely not convergent, and summation of n equals to 1 to infinity n equals to 0 defined by xk the partial sum of summation of k equals to 1 to kn, then which option is correct? First option say that xk equals to 0 for infinitely many k. Second option say that sk greater than 0 for infinitely many k and sk less than 0 for infinitely many k. If it's positive that sk greater than 0 for all k, it is possible that sk greater than 0 for all but a finite number of value of k. So here first given condition that summation of n equals to 1 to infinity an convergent but absolutely, that's mean mod of an not convergent. So I can consider a counter. So if an equals to 0 1 by n minus 1 by n 1/3 minus 1/3, this type of an we consider, then obviously summation of an equals to 0, their alternative sign exists, so it is obviously summation of an 0 definitely is finite value, this converging. But if mod this is 0 1 by 2 1 by 2 1 by 3, that is goes to infinity, not converging. So this I will consider this type of an. Okay, so obviously see that Sn means summation of n equals to 1 to k n. So if we summation this term by term, we get 0. That is for infinite many k. So this is all 0 for infinite many k. So option first is correct. So if first option is correct, so nothing greater than type or less than type. So second option is discard. Also third option discard. Fourth option is discard. I hope it is clear to everyone. It is only option 5 first is correct. Based on June 2012, questions say that fnx equals to 1 by nx for x belongs to closed 0 open 1 by n closed and 0 closed interval 1 by n to 1. So which option is correct? First option say that fn is defined continuous function on closed interval 0 1. Second option say that fn converging uniformly on closed interval 0 1. Third option say that limit n tends to infinity fnx equals to 0 for all x belongs to closed interval 0 1. And fourth option say that limit n tends to infinity fnx exists for all x belongs to closed interval 0 1. So obviously see that if we put x equals to 1, so obviously here see that first we put x equals to 0, so here 1, and 0 to 1 interval this limit goes to, this is 1 and 1 minus 1, that is 0. Okay, so if we see that x 0 to 1 this value gives 0 and x equals to 0 this value is 1. So not uniformly limit exist, so not UC not exist. So here exist for all x belongs to closed interval 0 1, but not UC not continuous not uniformly continuous, and for all value of x closed interval 0 1 it is not equals to 0. So here only option 4 is correct. I hope it is clear to everyone. Okay, it's done. Now go to next question. Next question based on CSIR NET 2012 December. Okay, their questions say that let f be a continuously differentiable real valued function on closed interval ab such that function derivative bounded, that means mod of f dash x less equals to 1 for all x belongs to closed interval ab for a partition p equals to a equals to a0 less than a1 less than an is equals to b. Let u fp and lfp denoted the upper and lower Riemann sum of f with respect to p. Then mod lfp less equals to k b minus a less equals to u fp. Second option say that u fp minus lfp less equals to k b minus a. Third option say that u fp minus lfp less equals to k norm of p, when norm p equals to maximum of a I minus 1 minus ai, and I belongs to 0 to n minus 1 is the norm of the partition, and u fp minus lfp less equals to k norm of p b minus a. Is it clear? Now here we consider fx equals to x polynomial function, definitely it is continuously differentiable, and if we consider mod f dash x that is less equals to 1, that is we consider k. Now find norm p. Norm p means, what is meant by norm p? Norm p means maximum of 0 less equals to I less equals to 2 mod a I plus 1 minus ai, that is maximum of 1 1, that is 1. Okay, now LFP is equals to, we know that summation of, it is lower sum, that means summation of I equals to 1 to 2 mi into xi minus 1 is equals to, we can find this is 2. Okay, and UFP, that's mean upper Riemann sum, that is summation of I equals to 1 to 2 mi capital Mi into xi minus 1. So here capital Mi, so 2 into 1 plus 3 into 1, that is 5. Okay, so obviously see that LFP is equals to 3 less equals to, not strict less than 1 into 1, so first option is discard, because first option say that LFP less equals to k into b minus 1, so we find LFP is equals to 3, and here k 1 and b minus a also 2, that is 3 not less 2, so it is incorrect. Second option say that UFP minus LP is equals to 2 not less equals to 1, so second option also discard, because second option say that UFP P minus LP FP less equals to K into B minus A is also discussed. Third option say that if we consider fx equals to x square term and also x belongs to closed interval 1 3, so f dash x less equals to 6, that is K, and find LFP, that is lower sum. And if we consider 3 partition 1 3 1 2 3, then lower sum, this is 1 into small m1 plus 2 into small summation of small mi into xi minus 1. So small mi, that's mean lower integral here function is lower integral is x square. First we find put 1 and second we put 2, that means 1 into 1 plus 2 square into 1, that is 5. UFP, put this and we get 13. So UFP minus LFP is equals to 8, that is not less equals to 6. So this is also incorrect. So first, second, third discard. So obviously option 4 is correct. I hope it is clear to everyone. Any doubt, please comment. Next question. This question based on June 2013. Question say that the power series summation of n equals to 0 to infinity 2 plus minus 1 whole to the power n by 3 to the power n x to the power n. Convert this only for x equals to 0. For all x belongs to belongs to R, only for minus 1 less than x less than 1, and only for minus 1 less than x less equals to 1. So here say that an equals to 2 plus minus 1 whole to the power n by 3 to the power n whole to the power n. Okay, so here minus 1 whole to the power n alternative sign exists. So first we put n is even term and second is n is odd term. So here n is odd term, we can find 1 by 3 to the power n, 3 to the power n times. If even term, that is 3 to the power n by 3 to the power n type, then we apply Cauchy-Hadamard test. So find limit extends to infinity mod an to the power 1 by n. So n, when n is odd, then we get 1/3. When n is even, that is we get 1. So mu, which is the value of mu means supremum of limit n tends to infinity mod an to the power 1 by n, that is supremum is 1. So this is mu, and radius of convergence r is equal to 1 by mu, that is 1. So here exist interval minus 1 to 1. It is clear to everyone, and so here option C is correct. And also we see that here minus 1 less than x less equals to 1. So first just we put x equals to 1, we get this integral, this summation. So this is not obviously because this is divergence. So option C is correct. This question based on CSIR NET June 2014. Question say that let Fn be a sequence of continuous function on R. First option say that Fn converges to f pointwise on R, then limit n tends to infinity minus infinity to infinity fnx dx equals to minus infinity to infinity fx dx. Second option say that if Fn converges to f uniformly on R, then limit n tends to infinity minus infinity to infinity fnx dx is equal to minus infinity to infinity fx dx. Third option say that if Fn converges to f uniformly on R, then f is continuously on R. Fourth option say that there exists a sequence of continuous function Fn on R such that Fn converges to f uniformly on R, but limit n tends to infinity minus infinity to infinity fnx dx not equals to minus infinity to infinity fx dx. Okay, so now this type of question is considered a function Fn x equals to 1 by n when x belongs to closed interval 0 1 elsewhere when 0. So fx equals to limit n tends to infinity fnx, we get 0 for all x. Okay, but minus infinity to infinity fnx dx is equals to 0 to 1 1 by n dx, that is 1. So this is the value of 1 by n and fx value is 0. So clearly it is not correct. So this is exist. So here equals to say that this is not correct. So first option is discard, second option is discard. So this is, and obviously say that if we consider fn is equals to 1 by n by mth test, we get limit n tends to infinity 1 by n goes to 0. So that is uniformly. So here say that fn convergent uniformly, f is continuous, it is okay. You see that's mean it is uniformly convergent. And fourth option say that there exists consider continuous function on R such that fn convergent you see, then it's not equals. So obviously this is also correct. So here option second and third third and fourth correct. I hope it is clear to everyone. Now go to next another question. December 2014. Let k be a positive integers. The radius of convergence this summation, this power series. So obviously we see that here a n term is n factorial to the power k by k n factorial. Now we just find mu, that is mu is limit n tends to infinity a n plus 1 by un. So just I apply limit n tends to infinity a n plus 1 by a n, and we get mu equals to 1 by k to the power k. So relation between radius of convergence and mu is reciprocal, that is r equals to 1 by mu. So definitely r equals to k to the power k. This option exists, option C. So here option C is correct. I hope it is clear to everyone. Now next another question, June 2015, and question say that for n greater equals to 1, let gn x equals to sine square x plus 1 by n, x belongs to closed interval 0 infinity, and fn x equals to 0 to x f gn t dt. Then fn converges pointwise to a function f on closed interval 0 infinity, but does not converge uniformly on closed 0 open infinity. Second option say that fn does not converge pointwise to any function on closed 0 open infinity. Fn converges uniformly on closed 0 1. And fourth option, fn converges uniformly on closed 0 open infinity. Okay. So first option, given function we can write here sine square x plus 1 by n, and fn is equals to integration 0 to x gnx dx. So this now first we solution this integral. So just multiply 2 to denominator and numerator, we get half x minus 1 by 2 sine 2 into x plus 1 by x plus 1 by 2 sine 2 by n. This is our fn x. Now limit n tends to infinity, fn x we get 1 by 2 x minus 1 by 2 sine 2x. This is limit of a function. Now find mod fn x minus fx. So now find fn x minus fx. This is fn x minus fx. We get here this is f plus 1 by 2 sine 2 by n, okay, minus this problem we can solve, and this is just put mod fn x minus fx, this is type, and we get here apply mod a minus b less equals to mod a plus mod b. So we get fn x minus fx less equals to 1 by n, and we consider this is mn. Then limit n tends to infinity 1 by n goes to 0. So so this is uc. So our option third and fourth correct. fn convergent uniformly on closed interval 0 1, and fn convergent uniformly on closed interval 0 to infinity. Now go to another question. Here say that this question based on CSIR NET 2015 December, and say that limit n tends to infinity summation of L k is equals to 0 to infinity k square x to the power k y to the power L by n factorial, then the series convergent xy, that is Cartesian product. Okay, so this type of integral separately we can solve. So here first we consider x to k square, that is a n type, and 1 by L factorial, that is n type. I mean to say that k square x to the power k, this is one summation under, and another summation 1 by L factorial y to the power L. So here a n this type k square, and here b n is equal to 1 by L factorial. So then by ratio test we get this value is 1 and this value is infinity. So if radius of convergent 1, So interval of convergence minus 1 to 1. So first x exists minus 1 to 1, and second is infinity. That means minus infinity to infinity is their radius of convergence, is their interval of convergency. So this type of relation which exists. So first option say that minus 1 1 is also okay. Second 0 infinity. So interval like minus infinity to infinity. So obviously 0 infinity also like, so also first option correct. Second option for are no, first x belongs to minus 1 to 1, so second option correct. Here fourth option are now second are, but first is like minus 1 to 1, this is incorrect. Here first option minus 1 1, it's okay, minus 1 1, so r exists, so obviously minus 1 1 also exists, so there this is correct. So here first and third option correct. I hope it is clear to everyone. Now second question, June 2016 CSIR. So question say that consider the improper Riemann integral 0 to infinity 0 to x y to the power minus 1 by 2 dy. The integral is continuous in closed 0 open infinity, continuous only in open infinity open 0 open infinity, discontinuous in open interval 0 to infinity. Fourth option, discontinuity only in open half to infinity. So first we solve fx and we get 2 root x. So obviously see that this is 2 root x, it is a continuous function, and 0 to infinity, so continuous 0 to infinity, which option exists? The option first exists, so here first option is correct. Now go to the another question. Define f on closed interval 0 1 by fx equals to x square if x is rational, x cube if x is irrational. Then which option is correct? First option say that f is not Riemann integrable on closed interval 0 1. F is Riemann integrable and 0 to 1 fx dx is equals to 1 by 4. F is Riemann integrable and 0 to 1 fx dx is equals to 1/3. 1 by 4 is equals to 0, lower integral 0 to 1 fx equal less than upper integral 0 to 1 fx dx is equals to 1/3, where lower integral and upper integral are Riemann integrable. Okay. So here note that f is continuous only at 0 x equals to 0 and x equals to 1 in the interval closed interval 0 1. Then there are uncountable many point exists, this is not continuous. So this type of relation, then the measure set of the point of discontinuity not 0. So point of measure is not 0, then the integral is not Riemann integrable. Okay. And so this type of relation is not Riemann integrable, so first option is correct. Second say that, so second obviously not correct. Third say that obviously not correct, so because it is not Riemann integrable. Now we check lower integral is equals to 1 by 4 and upper integral is check 0 to 1, upper integral 1 to 3 1/3. So this type of here x cube rational, and say that x square is rational and x cube is irrational. So x belongs to 0 1, say obviously x cube is small m type and x square is capital M type. So if we consider, if we lower integral find, that is integral 0 to 1 x cube dx, and if we upper integral find 0 to 1 x square dx, so find 1 by 4 and 1/3. This integral solve, normal integration solve, we get, so option 4 is correct. I hope it is clear. Now next question say that fn x equals to minus x to the power n, x belongs to closed interval 0 1. Then decision which of the following are true. First option say that they are a pointwise convergent subsequence of fn. Fn has no pointwise convergent subsequence. Fn convergent pointwise everywhere. And fourth option say that fn has exactly one pointwise convergent subsequence. Okay. So here say that subsequence case. So if we consider fn has subsequence 2n and 2n plus 1 type. So 2n types means, so if we consider limit n tends to infinity fn of 2n, that is x equals to 0 0 and x equals to 1 1. So exist, pointwise convergent subsequence exist. Is it correct? So option first is correct. Second say that no pointwise convergence subsequence, so obviously first is correct, so their second is incorrect. Fn convergence pointwise everywhere. Fn convergent pointwise everywhere, this means this is not a pointwise convergence everywhere, because if we consider x equals to 1, so f n x equals to -1 whole to the power n, so this is the oscillate sequence, so this is not a pointwise convergence, it is incorrect. Fs has exactly one pointwise convergence subsequence, no, here 2 is pointwise convergence subsequence, 1 is 0 and another is 1, so is also incorrect. So here option first is correct. I hope it is clear. So here this question for n greater equals to 1 and fn x equals to x e to the power minus n x square, x belongs to R, so then the sequence fn uc boleche, uc convergent on R, uniformly convergent only on compact subset of R, bounded and not uc on R, a sequence of bounded function. So first we find limit of a function, so fx equals to limit n tends to infinity fn x, that is we get 0. Okay, so now we this problem we solve by Mn test. So Mn test is say that supremum of x belongs to R mod of fn x minus fx, so supremum of mod of x e to the power minus nx square, so supremum, that's mean maximum, we get maximum value of this function, then which is the supremum of the function. So let this type of function we can consider y. So first we derivative, and if we derivative is equal to 0, we get find critical point. So here critical point is plus minus 1 by root 2. Now we put double derivative, then we get obviously less than type, so x equals to 1 by root 2n, this is our maximum point of this function. So here we put mn equals to 1 by root 2n e to the power minus 1. Now limit n tending to infinity, mn equals to limit n tending to infinity, this is equals to 0, so this is uc, so here option first is correct. I hope it is clear. So it is uc, so another all about question are incorrect, and say that f is bounded function and the sequence is a sequence of, here option 4 means unbounded function, say that this is incorrect. Bounded function e to the power minus n square is unbounded, so another it is say that a sequence of unbounded, say, so sequence is uniformly convergent and function limit is 0, that is bounded. So here say that fourth option say that a sequence of unbounded function, so this is also incorrect, so here first option is correct. This question based on CSIR NET 2016 December. Let fn x equals to 1 by 1 plus n square x square for n belongs to natural number, x belongs to R. Which of the following are true? Fn convergent pointwise on closed interval 0, 1 to a continuous function. Fn convergent uniformly on closed 0, 1. And third option say that fn convergent uniformly on closed half to 1. And fourth option say that limit n tends to infinity 0 to 1 fn x dx is equals to 8. So first we find limit of a function. So limit n tends to infinity fn x is equals to 0. So that is our limit of a function. So first we find left hand side and right hand side solve, we get same value. This is our true option. Okay. Now we find fn x limit. So limit n tends to infinity fn x when 0 to 1, open 0 closed 1, that is 0, and x equals to 0, we get 1. Okay, so limit different exists, so not uc, pointwise but not uc, so not uc. So here fn is pointwise on closed interval 0, 1, but 0, 1 to a continuous function, not a continuous function, because different value of x equals to 0, so it is not continuous function, so this is our incorrect option. Fn converging uniformly on closed interval 0, 1, fn converging uniformly on closed interval half 1, not uc, so obviously we see that this is not 1 exists, so here we see that this is also our incorrect option. And if we consider closed interval 0, 1, and we get if we put x equals to 1 by n, so we get obviously say that this is half, so not equals to, not uc, capital Mn equals to supremum of x belongs to closed interval 0, 1 mod of fn x minus fx, that is supremum of x belongs to closed interval 0, 1 1 by 1 plus n square x square, that is half, not equals to 0, so not equals to 0 is not uc, so this is also incorrect option. Option 3 2 is incorrect. And Fn convergent units uniform convergent on half comma 1, it is correct. It is correct. And option 4 is correct. So option 3 and 4 correct. This is interval is small interval. So if we consider half to 1, this is our correct option. So option 3 and 4 our correct option. Now our last question discussion, CSIR NET 2017 December, say that if such that closed minus 1 to 1 to r be a function given by fx equals to x square cos 1 by x if x not equals to 0, 0 if x equals to 0, then f is of bounded variation on closed interval minus 1 to 1, f dash is of bounded variation on closed interval minus 1 to 1, f dash x less equals to 1 for all x belongs to closed interval minus 1 to 1, mod f dash x less equals to 3 for all x belongs to minus 1 to 1. So first we find f dash x, we get this. So we know that cos x and sin x all bounded functions, so maximum value is 1. So we get mod f dash x less equals to 3. So option 4 is correct. So obviously option 3 is incorrect. And also we know that f is bounded, then f dash is bounded, then f is bounded variation. So obviously f dash is bounded, so f is bounded variation. So option first is also correct. And second option, f dash, if f double dashed, if we find f double dashed of x, we get which value, 2 cos x minus 2x sin x minus 1 by x square cos 1 by x. This is not a bounded function, so we can not say this is bounded variation. It is also incorrect. So here first and fourth option is correct. I hope it is clear to everyone. Any doubt, please comment. Thank you.